So this is block 1 general physics last topic, which is about the pressure. And we discussed already that how we can calculate the pressure. Pressure is how much force is acting on a unit area. If we want to increase the pressure, we should apply more force and we should reduce the surface area. And to calculate the pressure exerted by the liquid, as we know, liquid apply pressure in all the direction. So to calculate the pressure exerted by the liquid, as it depends on the density, depth, so we multiply the density with the depth, and with gravity we'll get the pressure exerted by the liquid. Before hydraulic system, the next topic is before hydraulic, the important topic is the manometer. It is also a part, but at the last I will explain this hydraulic system. The important thing is the pressure measurements. How we can measure the pressure, the instrument, the device which can be used to calculate or measure the pressure, that is a barometer. What is the purpose of the barometer? A barometer is used to find the atmospheric pressure. So if we want to calculate the pressure by the atmosphere, pressure due to the atmosphere, we use this barometer. Why the atmosphere is exerting pressure? Example, uh, this is a ground, a surface, and our atmosphere contains air, and air is a mixture of different gases. This oxygen is there, nitrogen is there, other inert gases, as well as carbon dioxide. So these are the particles which are present in air, and these are the gas particles. So if the gas particles are there, these particles are moving randomly. They are not moving in a specific direction, they all are moving randomly. So due to this random motion, when these particles hit the surface, what they will do, they will exert force. So when the particles hit the surface, so what they will do, they will exert force on the surface. So as they exert force on the surface, there is a force by the particle, and when they hit the surface, there is a specific area on which these particles are hitting. So force divided by area, the force exerted by the particle divided by area, what we will get? We will get the pressure which is exerted by this air. So this is the air pressure. As the air particles are moving randomly, they are moving in all the direction, but as they're moving in all the direction, they hit the surface. The moment these air particle hits the surface, they exert force on the surface, and when they exert force on the surface, force on unit area, it means they create a pressure, and this pressure is known as air pressure, or we also say that as atmospheric pressure. Is it clear the concept that why the air is exerting a pressure, or what is atmospheric pressure? The atmospheric pressure vary with from place to place, different atmospheric pressure, because it depends on the number of the particles. It also depends on the temperature of the air. It vary, but normal atmospheric pressure, the normal atmospheric pressure is equal to 100,000 Pascal, or we also say 100,000 Newton per meter square. This is a normal atmospheric pressure, or we also say atmospheric pressure at a sea level. But atmospheric pressure is not same, it is not constant throughout the earth. It varies even from place to place. Even on the surface of the earth it varies, because it mainly depends on the number of the particle, the temperature at which these particles are there. Example, if you are climbing a mountain and you reach top of the mountain, first you start with position A and then you reach position B. Which region the pressure is higher, on the surface or at the mountain? The atmospheric pressure or air pressure? Which region you think the pressure is higher? So when you compare the number of the particles, because the gravity of the earth is attracting the air as well, so there are more air particles on the ground. There are more air particles on the ground as compared to the number of the particles at the mountain. That's why it is difficult to breathe at a higher altitude as compared to that on the ground level or at a sea level. So what happens when we compare the pressure on the ground or at the sea level or the ground level, we'll have a high pressure, and when you move to higher altitude, when you climb the mountain, the air pressure will be low. So this is high air pressure and this will be low. And what is the reason for that? The reason is the number of the particles which are present, because as you move to higher altitude, the density of the air, the thickness or the number of the molecules of air are few. That's why they're exerting less force on you. As they're exerting less force on you, it means there will be a less pressure on at a higher altitude. So if I say at a ground level the pressure was 100,000 Pascal, at the sea level or a ground level it is 100,000 Pascal. What will be the pressure on the mountain? It will be more than 100,000, equal to 100,000, or less than 100,000. So what will be the pressure? It will be less than 100,000 Pascal. So even on the surface of the earth, because some regions are higher than the other, so even the earth surface is not exactly a perfect flat surface. Even on the surface or the ground level, there is a variation of a pressure, but normal atmospheric pressure is considered to be 100,000 Pascal. So how we can measure this? How we can measure this atmospheric pressure? So there's a device which is called a barometer. So barometer is an instrument or a device which is used to find the atmospheric pressure. How it works? Actually, it's not directly measuring the pressure. It is comparing the atmospheric pressure with the liquid pressure. What it consists of? It consists of a large tray or a container which is filled with mercury, and there's a test tube which is inverted on this large tray. So what happened? In the surrounding, we have air particles which are moving randomly. So as these air particles hit the mercury surface, so when they collide with the mercury surface, what they will do, these air particle will push this mercury so that the mercury will rise in the tube. So basically, the air particles which are moving randomly, they collide with the mercury surface. When they collide with the mercury surface, exerting force on the mercury and push this mercury, so the mercury will rise in the tube. So once the mercury rise at certain level, the mercury will stop rising. So once the mercury does not rise, what does it mean? It means the pressure exerted, because mercury is in the tube, so pressure exerted by the mercury in the tube balances with the pressure exerted by the atmosphere. So we can, once the mercury stop rising, so once the mercury stop rising, we can say the pressure of air or atmosphere equal to the pressure of mercury or liquid in the tube. Is it clear, this concept, that how we can use a barometer, and then how to calculate, that's the second part, but you should understand the working principle of a barometer. So what is the working principle of barometer? A barometer consists of a mercury, a liquid mercury. The air molecules are colliding with the mercury surface. So as these air molecules are colliding with the mercury surface, they force the mercury to rise in the tube. So here the level will decrease and the level will rise in the mercury tube. Once the mercury stop rising, it means the pressure of the mercury is same as the pressure of the atmosphere. And how we can find the pressure of the mercury? Because mercury is a liquid, so pressure exerted by the mercury or pressure exerted by the liquid is equals to density of a liquid multiplied by gravity multiplied by height. So example, the density of a mercury is fixed, which is 13,600 kilogram per meter cube. So if we say the density of the pressure exerted by the air or atmosphere matches with the mercury, so we can say that pressure of the mercury is density of a mercury, because it is a liquid, multiplied by gravity multiplied by height. So atmospheric pressure we can find by density into gravity into height. What is the density of the mercury? Density of the mercury is 13,600 multiplied by gravity. How much is a gravity? That is 10. And what about the height? What height we will take? The depth of the liquid from the surface in the container to the tube. This height we will take. Example, if this height is say 0.76 meter, so we will multiply it by 0.76. It can be any number. I'm just taking the values, random values. So 13,600 multiplied by 10 multiplied by 0.76. So the final pressure will be 103,360 Pascal. So that is actually the pressure exerted by the liquid. And because the mercury stopped rising at this point, it is not rising more. So we say that the pressure exerted by the liquid is matching with the pressure of the atmosphere. And we can work out the pressure of atmosphere by using the pressure of liquid. Is it clear? The barometer, the working of a barometer. So it's not a direct measurement, it is just a comparison. So this is how a barometer looks like, as you can see on your screen. At this point, we have a vacuum. Vacuum means no air particles. And what happened? There are air molecules in the surrounding. So as these air molecules hit the mercury surface, they will force the mercury to rise in the tube. So mercury will rise in the tube. As the mercury will rise, at a certain point, it will stop rising. The point where the mercury stops, what this shows that the pressure of atmosphere is equals to the pressure of mercury. And we'll not find pressure of atmosphere directly, we'll find the pressure of the mercury. And how to work out the pressure of the mercury? Because mercury is a liquid, the formula to calculate the pressure is equals to density of a liquid multiplied by gravity multiplied by height or depth. So density is fixed 13,600, gravity is 10. And what height we will take? We'll take the height from level of the mercury in a tube to a level of the mercury in a tray. Normally, at a sea level or at a ground level, this is normally, this height is about 760 millimeter or 76 centimeter or 0.76 meter. This is normally, but it is not fixed. It changes from place to place. So this height, if the pressure increase, more mercury will rise, the height will be more. If a pressure decrease, the height or the level of the mercury will also decrease in the barometer. So this is known as a mercury barometer, so which is used to find the pressure exerted by the atmosphere. Is it clear the working of a barometer and how we can use it to calculate the pressure of atmosphere? Any question or a doubt in mercury barometer? Now we'll do some questions related to topic pressure, so you have a better understanding. So we'll solve some questions related to topic pressure. Okay. You can also use screen annotation or a chat to state the answer. The diagram shows a simple mercury barometer. So this is a mercury barometer. They are saying the atmospheric pressure is increased. What is the meaning atmospheric pressure increase? It means that the force which these air particles are applying on the mercury surface, that is also increased. They're pushing it harder or pushing it with a greater force. With distance increase. So what happened when these air particles start to push this mercury? So this level will go down. So level X will go down. And what happened to level W? The level W will rise. So W will rise and X will go down. So the new position of X will be here. They're asking which distance increase. So when we compare the distance V and W. So first V and W was like this, but when the W rises, so V and W is not increasing, it is decreasing. So it cannot be A, because initially V and W was longer, but once the mercury rise in the barometer, V and W is decreasing. What about second option, W and Y? So when we compare W with Y, so because initially when you check, this was W and Y, but as the W rises, W is going up, so level is increasing. That's why W and Y, so B will be the right answer. Is it clear, this question? So the level of the mercury in a tray will decrease, in a container will decrease, and the level of the mercury, look, these are the original levels as you can see on your screen. They are saying the atmospheric pressure increase. So if the atmospheric pressure increase, this level, as there is more pressure, So this level X will go down. So new position of the X, this will be the new position of X. So level X will go down. So this will be level X. And what happened to level W? Level W will increase. So new position of W will be here. They're asking which distance increases. When you check V and W, so originally V and W was this, but now V and W, because the new position of a W is higher, so the distance between V and W will not increase, it will decrease. That's why it cannot be A. And why not X and Y? When you check X and Y, because the level X is going down, so originally X and Y was this distance, but now the level X is going down, so X will be closer to Y, so this length is also decreasing. So that's why it cannot be C. When you check D, level X and Z was like this, but next new position of X is below, so X and Z will also decrease. That's why B is the right answer for this. In this question, four different liquids are poured into four containers. The diagram shows the depth and the density of each liquid, in which container the pressure on its base the greatest. So how we calculate the pressure exerted by the liquid? The pressure exerted by the liquid is the density of a liquid multiplied by gravity multiplied by height. If density is gram per centimeter cube, the depth will be centimeter. But if density is in kilogram per meter cube, the depth will be in meter. Gravity is always fixed. The gravity is 10. So when we calculate the pressure exerted by A, so density is 3.1, gravity is 10, and height is also 10. So 3.1 multiplied by 10 multiplied by 10, that's equal to 310. So A is exerting 310. What about B? The density is 1.2, gravity is 10, and depth is 20. So when we multiply 1.2 multiplied by 10 multiplied by 20, that's equal to 240. When we check C, it is 1.3 times 30 times 10, or 10 times 30, because gravity is 10. So 1.3 multiplied by 10 multiplied by 30, that is equivalent to 390. And when we check D, it is 0.8 multiplied by 10 multiplied by 40. So 0.8 multiplied by 10 multiplied by 40, that is equal to 320. So which container exert the greatest pressure on the base? So that is container C, or C is the right answer. So whenever you are calculating a pressure exerted by the liquid, it is a density of a liquid multiplied by gravity multiplied by height. Four identical beakers are filled with equal volume of liquid P and Q. Liquid P is more dense, so this is having high density liquid, and liquid Q is low density. At which point the pressure is least, minimum? So we know the pressure exerted by the liquid increases with the density, and the pressure exerted by the liquid increases with the depth. So if we want the least pressure or minimum pressure, so first thing, it should have the least density and it should have the least depth. So first, the least density, which is having a least density, so it cannot be A or B because it is a high density liquid. So you're left with C. But when you compare the depth, C is having greater depth than D. So that is why the one which exert the least pressure, that is D. So D will be the right answer. But if the same question was there and they say which is exerting the highest pressure, maximum pressure, at which point the pressure is maximum, then what will be the answer? In that case, A will be the answer because A is high density and it is greater depth as well. Is it clear, this question? Abdullah Khan, Heather. The pressure exerted by the liquid depends on the density of the liquid and it also depends on the depth. So if we increase the density, the pressure will increase. If we increase the depth, the pressure will also increase. But in the question, they're asking at which point the pressure is least. So for the pressure to be least or minimum, because if density is high, pressure will be high. And if density is low, the pressure exerted by the liquid will be low. So we want we want a smaller value of a pressure by the liquid. So we want low density liquid and we want lower depth as well. So when we check the points A, B, C and D, which is having a low density and lower depth, so option D, it is a low density liquid, as they mentioned that liquid P is more denser than liquid Q. So liquid P is having more density or high density and liquid Q is having a low density. So when you compare, we want the density to be lower and we want depth also to be minimum. So the Q is having the lower depth and it is having the least density. That's what D is having. So that's why D is the right answer. Is it clear, Abdullah Sarfraz? Another question related to the pressure. So in question 4, there is an oil tank that has a base of 2.5 meters square. So in this question, you have an oil tank which is having an area of 2.5. So we have this area of 2.5 meters square. So this base area is equals to 2.5 meters square, and it is filled with an oil of depth 1.2. So there's oil inside. So oil is there, and the depth of this oil is 1.2 meters. The density of the oil is 800. So density is equals to 800 kilogram per meter cube, and the depth is 1.2 meter. In the question, they're asking how much force exerted on the base of a tank due to the oil. So first, to calculate the force, we should know the pressure exerted by the oil. So how to calculate a pressure exerted by the oil? The pressure exerted by the oil, because oil is a liquid, that is density of a oil multiplied by gravity multiplied by depth. Density of the oil is 800, gravity is 10, and depth is 1.2. So when we multiply 800 into 10 into 1.2, that will be 9600 Pascal. That is the pressure. But in the question, they're not asking for pressure, they're asking for the force. To how to calculate a force from the pressure. So if we know the pressure of the oil, so pressure is force divided by area. If we need the force, so force will be pressure multiplied by area. So pressure times area will give us the force. The pressure exerted by the oil, that is 9600, and the area of the tank, it's 2.5. So 9600 multiplied by 2.5, that is equal to 24,000. So force exerted by the oil is equals to 24,000 newtons. Is it clear? So we use both formulas. First, we calculate the pressure exerted by the liquid, and the second one, we calculate the force by using a formula. Pressure is force over area. Is it clear, this part? Any doubt in this question 4? The next question, the depth of the water is 65 meter. Like example, uh, say there's a pond or a river, and the depth of the water is 65 meters. The density of the water is 1000, and the gravity is 10. We want to calculate a pressure exerted. So it will be density into gravity into depth. Density is 1000 multiplied by 65 multiplied by 10. So it will be 650,000, or D will be the right answer. So some of the questions are direct questions. The next one, the diagram shows a simple mercury barometer. So this is a barometer which you can see. This is a mercury barometer. What is the length used to find the atmospheric pressure? Basically what happened, the air particle are exerting force on the mercury, which force this mercury to rise. And once the mercury stop rising, it means the pressure exerted by the mercury is equals to pressure exerted by the atmosphere. So how we can calculate the pressure exerted by the mercury? that will be equal to pressure exerted by the atmosphere. So density into gravity into depth. So which depth we should take? What is the level of a mercury we should take to calculate the pressure of the mercury, and using the pressure of a mercury we can get the pressure of atmosphere. So what is the length we should measure? So we always measure the length from level of the mercury in a tube to a level of a mercury in a container. So as you can see, this is not starting from 0, this is 10 and it is 12 here. So this number, it is starting from 12 and it is ending 80, 82, 84 and 86. So this level is 86. So what is the height here from 86 to 12? So the difference, the length here, so 86 minus 12, that is equals to 74 centimeter, because the ruler, the scale is in centimeter. So it is 74 centimeter. Is it clear, this one? So this height we will take to calculate the pressure exerted by the mercury, and that pressure of the mercury will be same as the pressure of atmosphere. Is it clear, this example? Only I can see your chat result. So this was about the barometer and some question related to the previous topic of pressure. I'll share another link and explain a topic, manometer.